Okay, so we're talking about here significant figures. Now, in this video, we're just going to talk about the basic rules for finding the number of significant figures in a measurement. If you're looking for an explanation of why these rules exist, check out another video we're going to post soon. This one's going to be just on the actual rules themselves and how to use them. So again, the whole idea is to find the number of significant figures or significant digits in a measurement. Okay, so that's our purpose. And we've got several different rules that are going to help us do it. So first rule would be any non-zero number or digit is significant. Okay? Any non-zero digit is significant. So in a number like 352, would have 3 significant figures. A number like 27 would have 2 significant figures. 4,765 would have 4 sig figs, and by now I'm sure you get the point. Anything that's not a 0 is always going to be significant. Okay? The next one is probably the easiest of the rules to deal with zeros. Any sandwiched 0, which is between 2 other significant digits, is significant. Okay? Any sandwiched 0 between 2 other significant digits is going to be significant. So in a number like 305, 3 and 5 are both significant, so that means 0 is as well. This would have 3 significant figures. If I had the number 40,003, 4 and 3 are both significant, which means all the zeros in between them must be as well. So this would have 5 significant figures. Okay? Any zeros between 2 numbers that are already significant are also going to be significant themselves. So let's go ahead and take a look at some of the more interesting rules. Rule number 3. Zeros that are placeholders for a decimal are not significant. Zeros that are placeholders, let me get that out of here, that are placeholders for a decimal are not going to be significant. Okay? So anything where we have placeholder zeros, examples of placeholder zeros would be ones that just modify the size of a number. Okay? That when you take them out, they will change the value of the number. For example, 6,300 grams. If I take these 2 out, the number changes would be 63. And what it does, these things basically just tell us that those 2 zeros are holding places for basically holding place values. So this thing has 2 significant figures. If I had the number 0.003, these zeros are all placeholders. They tell us how small that 3 is. This would actually only have 1 significant figure. Just make sure, keep that constant. Likewise, if you had the number 500, those 2 zeros are just telling us that we have 5 100s. They are holding a place. This thing only has 1 significant figure. On the other hand, if we were to look at the number 500.1, well, this 1 and that 1 are also significant, which means these zeros must be as well. Okay, these zeros would not count as placeholders. Okay, so this would have a full number of 4 sig figs. Okay, so placeholder zeros, ones at the end of a non-decimal number, ones at the beginning of a decimal number, those guys are not significant, and we can ignore them. Okay. Your fourth rule is zeros at the end of a number with a decimal are significant. So, if I was dealing with the number 5.00, these zeros are at the end of a decimal, end of a number with a decimal, which means they are significant. I would have 3 significant figures here. If I had the number 0.0030, these are placeholder zeros. They come before the number. They're larger than the number in this case. This 0 is at the end of a number with a decimal. So this would have 2 significant figures. Okay. If I look at the number 400 with a decimal, decimal's here, which means any 0 at the end does count, and 4, because it's not a 0, also count. This would also have 3 significant figures. Okay? This is one of the trickiest rules, but with a little bit of practice, you'll be sure to get it. Okay? Our last rule is number 5. Exact numbers, those that are counted or defined, have infinite significant figures. Or we'll say infinite significant digits. So, for example, 12 items per dozen. 12. All right, that's an infinite number of significant figures because this is a definition. If I was to look at, how about 1 kilometer is 1,000 meters. Now I might look at this 1,000 meters and go, oh, there's only 1 sig fig there because these zeros are placeholders. But since this is a definition, there's actually infinite significance there. The last one, so a number like counting. So for instance, if we were to make a bunch of dots here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 dots. That's a counted number, and that number would have infinite number of significance. So I hope this quick overview helped. We're going to be getting plenty more practice in class. Make sure you follow along.